So to simplify these radical expressions, we want to make sure that we have these in mixed radical form, in lowest form. That way we can compare if the radicals are like radicals, which means we can add or subtract them. So here we take out the perfect square, so it becomes 3 root 4 times 2. And here we have a perfect square of 25, so we have root 25 times 2. When we take out the perfect square, we end up with 3 times 2 or 6, and left inside the radical is our 2. Here, same thing, we take out the perfect square 25 on the outside, and left on the inside is 2. At this point, we have to check to see if these radicals are like. So in this case, they are, because we have 6 root 2's here, and we have 5 root 2's here. So if we have 6 root 2's and we take away 5 root 2's, we're left with 1 root 2. So we can always check this with our decimal with calculators and see if 3 root 8 minus root 50 is the same as root 2, which it was. Here we want to get rid of we want to rationalize the denominator, which means that we need to make perfect cubes, since this is a cube root. So to make a cube root, we need to multiply the denominator, first of all, with the cube root for the same index. And we need to know what number times 49 will give us a perfect cube. So this is 7 times 7. So if we multiply by one more 7, that will give us a perfect cube. We need a perfect cube for x's. To do that, we need to multiply by x squared. Okay, so in this case, the denominator now will give us a perfect cube, okay, the cube root. 49 times 7 is 343 x cubed. Okay. Now when we multiply the bottom of this radical with this amount, we need to multiply the top by the exact same thing, otherwise we're going to change the value of this fraction. And what happens then is, although we have a radical on top, that's okay, because we're trying to rationalize the denominator, not the numerator. So this simplifies then to 3 cube root 7x squared over the cube root of 343 and the cube root of x cubed. So there it is. There's our final answer. Here we can simplify this fraction first before we try to add or subtract or combine like terms. So here since this is division, we can distribute this way and this way. Okay, so we have the fifth root and the fifth root; those are compatible. So I'm going to end up with, well, there's no factor that will work with a 4. So we're going to first of all divide. Looks like here we're going to end up with the fifth root of, how should we do this? Now, let's keep the fifth root of 9 in the denominator, since it doesn't work with that one. And let's divide x8 with x, so we end up with x to the power 7. Okay, and the 8 stays up the top there. Now, it looks like this does not simplify. Okay, we could simplify this. The one part we could simplify is we could take out the perfect power of 5 and leave the x squared inside. Okay, so this is about as far as it will simplify. Okay, so doing the second part here, which I'll do in a different color. Second part of this binomial term. Okay, we can do 2 divided by 4. So that's going to become 1 and 2. We can simplify that ratio. 81 divided by 9. We can say that's equal to 9. And then x7 divided by x. We're going to end up with x6. Okay, again, the 9 is not a perfect power 5. We do have a perfect power 5 here, which we could take out. So we're going to take out an x. We're left with the fifth root 9x. Okay, and that's all over 2. So there it is. We've just distributed that division, and it looks like that's as far as it will simplify.